Here's our patch. Each patch, as you may know, is individually designed by the crew. Our mission really began with the completion of the service module after a 2-year delay. And here it is during the rollout ceremony in Russia. It was launched in July on top of a Proton rocket. And it rendezvoused and docked with the rest of the space station, which again had already been in orbit for over 2 years. You see animation of the functional cargo group and the American-built node. And that brought us to September. At first we didn't think the weather was going to cooperate. Here we are getting suited up about 4 hours prior to liftoff. That's me, the commander, Scott Altman, our pilot, Navy F-14 pilot, Ed Liu, mission specialist number 1, Rick Mastracchio, MS-2, our flight engineer. He's getting suit pressurization checks. Dan Burbank, Coast Guard helicopter pilot, MS-3. Yuri Milenchenko, MS-4, colonel in the Russian Air Force, also a commander of the Mir space station. And Boris Morkov, Russian flight surgeon. Here we are about 3.5 hours prior to liftoff during crew walkout from quarantine. We've been in quarantine for 1 week prior to launch. And again, at first we didn't think the weather would cooperate. You can see all the clouds, but fortunately the sky cleared just in time for the launch. Space shuttle main engines, they light about 6 seconds prior to liftoff. That gives the onboard computers time to check out the engines, make sure they're operating 100% before they actually give the launch command. Here's an inside shot, and you can tell when the solid rockets light. A lot of shaking. You get about 7.5 million pounds of thrust. It feels like that too. At first we go straight up to clear the pad, then the shuttle begins a roll program to head us up to the inclination to intercept the International Space Station. There's a total of 8.5 minutes during ascent. The first 2 minutes are spent on the solid rockets, and then once they're expended, of course the rest of it is done on the 3 main engines. Here's a good shot of the shock wave that's formed as we go through supersonic flow. You can see the moisture being squeezed out of the atmosphere, covering about half the shuttle and the solids. Again, after 2 minutes, the fuel is used up out of the solid rockets and they're jettisoned from the stack. Here's an interior shot for a night launch, and of course even in a day launch, that flash out the windows is looks a lot brighter than what you saw in the film there. The solid rockets are reused. There's a parachute in the nose. We have a couple of ships out in the Atlantic Ocean that recover them, haul them back in. They're refurbished and used on a future launch. Here we are at MECO. The main engine just cut off, and after being pushed back in your seats about 3 Gs, suddenly it has no Gs. We put our hands up. You can feel a false sense of pitching forward. And the external tank, as it drops back into the atmosphere, you can see some venting there. Now that we're in space, we open up the payload bay doors. Our radiators are stored in these doors, which is how we reject heat. If you look along the right side of the picture, you can see the Canadian-built robotic arm. In the back, we have the Space Hab pressurized logistics module. And next up from that is the SHOSH box, or our EVA toolbox. And then up close in the bottom left of the screen is the actual docking mechanism we use to capture the space station. We get set up to live in space. We can see most people start playing with their food right away and enjoying being in zero gravity. On flight day 3, we rendezvoused with the space station. We actually rendezvous from below. Then we fly halfway around to the top and dock with the station from above. We use a camera that looks right through the docking mechanism in the payload bay of the orbiter. Here's that camera. You can see some of the 3 wires that intersect, and there's a washer with a target right in the middle of the docking mechanism. And we use that to more or less bullseye the station while we fly around it. Here's a good view of the station. You can see the progress module at the bottom, then the new service module with its solar panels, then the FGB, and finally at the very top of the stack would be the American-built node. Here we are nearing the top. You can see the American-built node, and the actual docking mechanism and target on the space station is right at the tip of the node. Some of the rendezvous was at night, since we get a day-night cycle every 45 minutes. And we have tools on board, sensors on board, that let us fly through the darkness. But as we get in close, we would hold our position and wait for daylight to actually do the docking. You can see Rick using the handheld laser out the back window, Dan operating the cameras, and you can see the target on the screen in the background there. Here's the actual docking. It's amazing, flying at over 17,000 miles an hour, you can fly the orbiter to within basically a tenth of an inch of another target traveling the same speed. It's quite a space vehicle. Once we actually docked, then Dan operated the mechanism to actually lock onto the station.
This is a shot coming down the tunnel to the Space Hab module. For our mission, the Space Hab was used to carry up supplies and equipment to the space station. You can see some of the large batteries mounted to the back wall, strapped to the walls and floors, filled with equipment that we transferred over.
The first thing we had to do that day was to check out our spacesuits, which was going to be setting up for the spacewalk, which was going to occur on the next day. What we're doing here is looking at the jet backpacks, which we would use in case of an emergency. On the actual flight day, you climb into your spacesuits, which are in the airlock. That's where these scenes take place. You actually crawl up inside your spacesuit, pop your head out through the top. This is Yuri Malenchenko. It's his third spacewalk.
This animation of the shuttles shows the shuttle docked to the space station with the robotic arm stretched out over the shuttle towards the station. The main task of the arm was to lift the two EVA crew members, Ed and Yuri, out of the shuttle's payload bay and place them about 50 feet up on the station.
From that point there, we'll climb hand-over-hand style along handrails along the side of the space station all the way up past the FGB, which you see there, to the upper part of the screen, which is the service module. The entire stack at this point is about the height of a 13-story building, and we'll be going up to about 11 stories up on there. So the first thing we do is climb out of the airlock and attach our tethers to the robotic arm, which we'll later use to get a ride halfway up. And then we go back in the payload bay of the shuttle where our tools are located, which are in this big box back here. Inside the shuttle, we've got Rick and Dan inside there, and Scooter in the foreground. Dan was our choreographer. He'll be monitoring the checklist for us, and Scooter and Rick will be running the arm. So when we get outside, we open up the box with our tools and carry these things out. What we're going to do with all of our tools and equipment is attach them to the backs of our suits. It turns out that we're going to go far enough up the space station that we don't want to make two trips. So we're going to carry all of our equipment with us. What you see there are cables and clamps which are going to connect between the newest part of the space station, the service module, and the FGB. So once we attach all of our tools and our cables, we grab onto the shuttle-based arm, and Rick drives us up to about the 4th floor on the space station. From there, we climb back off the arm onto the FGB and begin climbing up. One of the first things we had to do is release a docking target, which did not deploy as it should have immediately after the service module launch. After that, we worked all the way out to the back end of the service module, again about 11 stories up. And our first task was to install a magnetometer. What that is something like a three-dimensional compass. And what we do is we attach it to a long pole, which holds it away from the hull of the service module, which keeps it away from any electrical currents inside, so that it can get better readings of the Earth's magnetic field. From there, we work our way backwards and begin installing a series of cables between the service module and the FGB. On the right, you can see Yuri pulling along a reel of cables. I'm on the left, attaching the cables to a connector panel. We actually lay out a series of clamps which hold the cables in place between the two modules. It goes from dark to light pretty rapidly. In fact, it does it 16 times a day. And you can see here how quick light during a sunrise. And because of that, we actually have to make sure that we have a bit of an advance notice from our choreographer inside, Dan. Here's Dan telling us that we're coming up on a light pass. What we need to do outside is prepare our suits by turning off heaters on our gloves and raising our visors and turning off some lights on our helmets.
Well, this shot gives you a little bit of the perspective on how far away they did most of their work during the spacewalk. We actually only had them in view with cameras from the payload bay and the arm for almost the entire spacewalk. After about 6 hours of EVA, we used the arm to pick them up, give them a ride back into the payload bay where they stowed the tools that they used and then headed back into the airlock. Then we moved the arm and put it away and got ready for the next day's big events. And that was the first ingress into the space station. Ingress is basically a process of opening hatches and configuring the air ducts. There's actually 14 hatches that we had to open as we headed our way into the space station. First element we come to is the node. That's the center point, the connection for all the future modules of the U.S. part of the International Space Station. From there, the next spot is the FGB. And that's the first element of the U.S. and joint U.S.-Russian element that was launched in space. And at the end of the FGB was a hatch we'd been looking forward to, the entry into the service module, as we were the first people to enter that after it had been launched into orbit. We went in, configured the lights, got everything warmed up, and set about our mission task of making this element a home for the first expedition crew. Touring the service module, the first thing you come to from one end is the toilet. We configured that and made it operational, even including a mirror for them to use shaving in the morning. Around the corner from the toilet are the crew compartments, one on each side. They each have their own door, so each crew member has a little bit of privacy, a little space to call their own. You can see there's gear in the back there that was launched in place, bolted down for the launch loads. One of our tasks was to remove that. But even with that gear in place, there's still enough room for me to squeeze in and have a couple moments to maybe take a quick little nap during the middle of a busy work day while everybody else is busy with the door closed. It was a nice quiet spot. Here you can see that equipment's now been removed from the wall and placed in bags where the crew members, when they came on board, could just pull those bags out and clip up their sleeping bags and be ready to go. You can also see the porthole in that area. This is the food preparation area where they're going to make their meals. Oxygen generation system, harmful contaminants removal system, basically an air conditioning system to make sure that the air on board stays safe for all the inhabitants. In the middle, there's a stationary ergometer, basically a workout bike that you can pedal to get your heart rate up to help your muscles stay in shape from atrophying too much during the space flight. One of the things I liked about this was the porthole right in front of us there. You could open that up and while you were biking, basically ride yourself around the world.
Right off the bat on the ingress day, we're all hard at work removing launch restraint bolts that secured a lot of the panels in place during launch. So we remove all those bolts, open the panels, and start preparing the spaces behind them to accept the equipment we're about to be installing over the next couple of days. Yuri's here in the foreground working on the area where one of the carbon dioxide removal systems will be, and up forward, Boris and I are working on the caution and warning panel. This panel right here is used to remotely dock vehicles to the space station. This area here is the controlling post, or the bridge, if you will, for the service module. In the upper left is the caution and warning panel, and that table there will basically support one of the Russian segment laptops that will control the systems.
This scene is from inside the FGB or Zarya module. You can think of it as a big storage closet, and that's why one of the walls and the floor are covered with bags of equipment. Here's Ed Liu coming into the picture. He's transferring the first science payload over to the International Space Station, a protein crystal growth experiment. We brought over lots of equipment, tools, food, water, and clothes for the first crew that will live on the station. We also transferred life support equipment, exercise equipment, and 5 batteries. Here I am transferring one of the batteries over. They weigh over 150 pounds. Not only did we transfer them, but we installed some of them.
Not all the installations were easy. In fact, installing one of the batteries in the FGB, we had some problems because a bracket here in the middle of the view had some obstructing hardware that we had to remove, and it actually took a hammer and chisel to free it up. We're a little bit surprised to find those on board Space Station, but the folks who set it up thought of everything. We finally got those 2 batteries and associated equipment installed in the FGB and squared all that away.
The reason we had so much equipment to install was that the service module was too heavy to launch with most of its electrical system and life support system installed in place. So we actually carried those up inside a progress module and inside the shuttle, brought them up with us, and installed them. You can see Yuri and myself here attaching parts of the electrical system underneath the floor of the service module. Beyond that, we also installed a large treadmill, which is going to be used by long-term crews up there to exercise. The interesting thing about this treadmill is that it's big, and it's gyro-stabilized. It weighs about 900 pounds, and it is a vibration-isolated treadmill, which allows you to run on top of it without shaking any other part of the station. It actually hovers in this pit in the floor. So it's connected loosely by some thin cables, but otherwise it stabilizes itself when you run on it.
Now, not all our time was spent working inside the space station. We also had some opportunities to look outside and take pictures. We saw some incredible sights, like this view of the southern lights, the Aurora Australis, as we flew through just some beautiful green and red lights streaming up from the Earth. It was incredible. A lot of opportunity to look at islands and coastlines. Here we are coming across the Mediterranean, headed towards the Libyan coast. Some great views of Europe, the United States. This is a shot of the coastline of Italy as we crossed over. We also saw some parts of the world I was familiar with from the ground side, like this shot of the Straits of Hormuz, the entry into the Persian Gulf that I had gone through on board an aircraft carrier just a few years before. But near the end of our mission, we'd finished all our work on the service module, and it was time to start closing the 14 hatches between us and the space shuttle as we headed our way back to our shuttle to get it ready to head home. One of the things we worked hard at doing, in addition to shutting all the hatches, was making sure that we brought home everything we were supposed to and left behind all the things that the expedition crew were going to need. The day after that, it was time to undock. The pilot actually flies the undocking from the aft control station. We flew 2 complete laps around the space station to give us a chance to look at it from some different perspectives and in different lighting conditions than we'd seen on our rendezvous. Dan pushed the button, and the hatches slowly came apart as we undocked here. The pedals disconnected, and we backed straight out from the space station to about 400 feet before we started our circuit around there. You can see my left hand putting commands into the system to fire jets and maneuver the space shuttle around the station. We just watched it rotate in front of us as we flew around about 400 feet away, silhouetted against the blue of the ocean, with the sun coming up and making the solar rays just glistening gold in the sunlight. It was really an incredibly beautiful sight. But after 2 laps, we were over Baikonur, where the space station had launched from, and it was time for us to say goodbye and do our separation burn.
We all got kind of spoiled on board Space Station because there's so much volume to live in. So here's what it would typically look like during a meal on the middeck with 7 big guys all trying to fit in there. The way the meals work is a lot of the food is pre-packed, dehydrated, and freeze-dried, just like these scrambled eggs. But some of the food also comes up like you might see it in a store. We've got nuts, tortillas, fresh fruit, and things like that. You've also got some meals that are just like the military-styled MREs or meals ready to eat. And you can just heat those up in a convection oven. As for the stuff that's freeze-dried, all we do is we use the galley to inject water. You select how many ounces you want, whether it's hot or cold, and just kind of mix it around a little bit, and in anywhere from 5 to 10 or 15 minutes, it's ready to eat, and actually pretty good. We also had a little bit of time to enjoy ourselves. Here we are, Yuri showing me some tricks in the Space Hab. This is not something you'd want to do right after a meal, but it is an awful lot of fun. This is what it looks like from my perspective. It's important in space, as they say, to stay hydrated, and Yuri's showing us one way to do that. Surface tension holds a ball of water together like this until you're ready to go ahead and drink it down. So here he is toasting the success of the mission. It's also important to exercise, even if you're up there for just a 2-week mission. So Rick is working out in the ergometer on the middeck of the shuttle in a normal way, and this is how Scooter would prefer to do it, doing his tried and true fly-around technique. At the end of the day, you go ahead and strap your sleeping bag up to the walls or the ceiling or the floor, and you climb in and go to sleep, and you actually sleep very well up there. It's like being on the softest bed you can imagine.
On our last day in orbit, there's a lot of work to do. We need to put away the equipment that we used on orbit. We need to install the seats for entry, and we need to get into our launch and entry suits. You tend to grow about 1 or 2 inches in orbit, so sometimes your suit is a little tighter than it was when you left the Earth. But luckily, we had no problems here. We do our deorbit burn somewhere over the Indian Ocean, as shown on this map here, and that's about 12,000 miles away from our landing site in Florida. We're traveling over 17,000 miles per hour, and our deorbit burn only slows us down by about 200 miles per hour. So when we re-enter the atmosphere, we're traveling pretty fast, and we get a really good light show. We get these bright flashes out the overhead windows as the plasma goes around the vehicle, and out the front window you can see the glow of the nose as it heats up. It kind of goes through various colors as it heats up. It's a great show.
Here's the actual view out the pilot's window. You can see the depiction of the landing runway there at the top middle of your screen. We landed at Kennedy Space Center where we took off. This is the view out of an infrared camera, and of course the wider something is, the hotter it is. You can see the nose of the orbiter soaks up most of the heat during re-entry. The black rectangles are the landing gear that Scott just put down. They come down at 300 feet or about 15 seconds prior to touchdown. Here's a view of the actual runway, and during the landing you can see us going through 250 knots, out 80 feet, and then the touchdown again. The space shuttle, since it's reusable, it comes back to Earth, lands like a big glider. We have 3 landing spots. Here's the drag chute coming out. Helps slow us down. We touch down over 200 miles an hour, and that's decelerating again from over 17,000 miles an hour. As it goes down the runway there, again, you can see the engine bells are hot. The tires from rolling down the runway have picked up a lot of heat. And again, the chute. Here we are with the orbiter back on the runway. The folks at Kennedy Space Center looking it over. Since we did a good job, our boss, Mr. Golden, greeted us. We're welcomed back to the Kennedy Space Center by the people that gave us the shuttle. And by the way, it surely behaved well. We were given a great orbiter. Here the press is welcoming us back. And that was the end of STS-106. Of course, that's not the end of the space station. We're going to fly about 8 missions a year for the next 5 years, completing construction. By the time they finish, it'll be as big as 2 football fields and 4 times the inhabitable volume of the Mir space station. It'll have 5 laboratories, and a lot of world-class research will be done on board.